Hope you are well this morning. I would like to welcome all of you to the World Future Foundation PhD Prize in Environmental and Sustainability Research Award Ceremony. Please take your seat. First and foremost, I would like to thank His Excellency Wei Wei, Amsterdam Extraordinary and Plenipotentiary from China Embassy, Mrs. Vanaja K. Cheket, First Secretary and Head of the Chancellery from the High Commission of India, Mr. Sun Zhiping, Third Secretary from Education Office at the China Embassy, Dr. Feng Lun, Chairman of the World Future Foundation, Professor Tan Tian Sun, National University of Singapore, Vice Provost Academic, Vice Provost Education, Professor Lai Sun Wa, Associate Dean Academic at Nanyang Technological University, guests, colleagues, and friends from the media. Thank you all of you for taking your time to attending this award ceremony this morning. My name is Wang Yan, and I'm your MC today, plus one of the inaugural winners of the World Future Foundation PhD Prize in 2010. I'm happy to be here again to attend the award ceremony with my peers and juniors. Without further delay, please welcome Professor Tan Tian Sun to deliver his welcome address. Professor Tan, please.
His Excellency Wei Wei, Ambassador of the People's Republic of China, Mrs. Vanaja Tekat, First Secretary and Head of Chancellery from the Indian High Commission, Dr. Feng Lun, Chairman of World Future Foundation, Professor Lai Sun Wo, Associate Dean, Academic NTU, Prize winner, friends, colleagues, ladies and gentlemen. It's indeed my great pleasure to welcome all of you to our beautiful university town this morning for the third annual World Future Foundation PhD Prize in Environmental and Sustainability Research Award Ceremony. The world today is confronted with many pressing challenges, a number of them with potential existential impact on mankind. Climate change, resource depletion, environment degradation, aging populations all require urgent solution. The weather extremity that we have witnessed all around the world over the last few years, the critical lack of clean drinking water in many parts of the world, and the continued large-scale degradation of the environment are just some of the underlying factors that have added stresses on society. We also know that business as usual will no longer be enough. It is no longer sufficient to repeat the same processes that were done in the past, even if they were to be done more efficiently. Incremental changes may not be enough, as in many areas and aspects, we are near to crisis or tipping point. Nevertheless, the history of the world has always been written by young people who has risen time and again to meet those challenges head-on and find new innovative solutions and allow the world as we know to continue to grow and prosper. I'm optimistic that this will be the case again. But for this to happen, we need to inspire some of the our young brightest mind to devote their attention and turn their passion towards mitigating these challenges. It is therefore pivotal for you, the young scientists and engineers gathered here today, to research and develop this innovative solution to help the world to head off the looming challenges. It's also true that often this does not happen by chance, and this young mind needs nurturing. Today's ceremony is a part of that effort to recognize, to inspire, and to nurture some of our brightest and most talented students to come forth and help the world to tackle these challenges. For this, I am very grateful to Dr. Feng Lun and the World Future Foundation he founded for so generously supporting this PhD Prize for Environmental and Sustainability Research. Dr. Feng recognizes the pressing need to encourage and inspire more talented young researchers like all of you and the past winner to devote their work to tackle and develop sustainable solutions for the many challenges that the world faces today. NUS is indeed privileged to be a partner for this collaboration with WFF as the university strives in its pursuit to excel in growing and mapping the research capability in Singapore and beyond in sustainability arena. Besides this WFF PhD Prize, WFF is also the sponsor of the Vertical City Challenge, where architectures from 10 of the best universities around the world come together in a competition to develop new innovative solutions to the many and multifaceted problems faced by many cities, especially in Asia. It is also an opportunity for peer learning among this diverse group of students. And it is through such intercultural interaction that great ideas will be generated. This competition is ongoing at this very moment in our school and design environment building. And with 20 teams of students from great institutions like Tsinghua and Tongji University from China, Tokyo University from Japan, the Chinese University of Hong Kong, Berkeley, Michigan, and Pennsylvania from the United States of America, and Delft and ETH, Switzerland from Europe, and of course, students from NUS. This is yet another of our joint effort with World Future Foundation to spur young students to think out of the box and look for innovative solutions to address the pressing need of high-density city. These initiatives are just a small part of NUS' overall effort toward addressing the pressing challenges faced by the world. NUS has set up an integrative sustainability research cluster to promote interdisciplinary work in our quest for new innovative solutions that takes into account scientific breakthroughs, technical innovation, and social responses. I am also responsible for the work of this cluster in NUS. To our winners today, your academic pursuit for excellence does not end here. This is only the beginning of your journey to leapfrog to the next level of excellence. Further, I'm very happy to share with you today that Dr. Feng has further sealed his commitment to this cause by indicating that he will provide future funding support to our winners to support them on worthwhile projects. So, all the winners, both present and future, take note. So, on this note, congratulations, and I wish all of you, I wish you all the best. Thank you.
Thank you, Prof. Tan, for addressing us. Next, please welcome Professor Lai Sun Hua, Associate Dean Academic at the Nanyang Technological University, to give his speech.
First and foremost, good morning to all of you. Good morning, His Excellency Wei Wei, Ambassador Extraordinary and Planetary China Embassy. Thank you for gracing the occasion. Mrs. Vanaja Takat, First Secretary and Head of Chancery, the High Commission of India. Dr. Feng Lun, Chairman of the Board of World Future Foundation. Thank you for initiating this award. Professor Tan Tiam Soon, Vice Provost Education, NUS. Thank you for hosting this ceremony. Distinguished guests from Embassy as well as from the board of World Future Foundation, students, eminent students, I would say, ladies and gentlemen. Well, today marks a very important occasion. It speaks of the achievement of the next batch of World Future Foundation. And there is certainly a cause for celebration, both to the people who made the achievement, the achievers, the donors, as well as NUS and NTU who are part of this endeavor. And we certainly would thank very much World Future Foundation for this opportunity to share their so-called endeavor with us, particularly in giving us the award at the doctorate level PhD in Environmental, Sustainability, and Future Metropolis Research. We are grateful for the awards. It is US $10,000 per student, and it is a significant amount, I would say, by any measure. And I would say that it also is a very calculated, wise decision too, because it plays heavy weightage to the important and life-changing resource that are facing us today, as already very well articulated by Prof. Tan. The world is facing this change. How do we best manage our resources intelligently and usefully? So this PhD prize in environmental and sustainability is a testimony of the deep concern that WFF has, as well as NTU. In NTU, under our strategic plan blueprint, Sustainable Earth, we call that Sustainable Earth, is one of the 5 peaks of excellence that is in NTU. We have fantastic funding resources being placed down there. And it also highlights the importance that NTU plays in this to put a global stamp by building the university current strength and heritage. So this collaboration with the World Future Foundation is therefore timely, and is something that we look forward to continue building with World Future Foundation and other world partners to be part of it. One thing for sure, this gift would certainly enhance and spur more students to provide fresh insight, if not only just in terms of solution, but if there is any other spin-off, it is certainly to create a greater awareness, certainly raising the bar of competency in this area of work. I was looking at past statistics. When we first started off in 2010, there were only a reasonable number of nominations. This year, at least from NTU, we received 34 top quality nominations from the school out of 400 possible candidates. It certainly bears testimony to the growing stature of this award in this exciting multidisciplinary field, as evident by the number of nominations received over the past 3 years. It has been growing. And by each growing, we found that the quality, not just in terms of quantity has increased, the quality has also improved tremendously. And I'd just like to share with you what our observation. For this year, the selection of our graduates has been increasingly challenging. Why? Because among quite a number of these candidates, for consideration, many have sort of published papers. In fact, that is just only the minimum requirement. Some have even filed invention disclosure, patents. Secure even right at this beginning, already secure sizable research grants. One of them even have published as many as 50 international papers. Quite a number of them even scored A's in the research curriculum and won many study awards. So really, in a nutshell, I do not know how the selection team go and select from this group of people. All I can say is that from all those nominations, I would say all the nominations are worthy winners by themselves in their own right. So it's really a feather in the cap for the shortlisted winners, to receive this prestigious award. On their selection, these graduates have not only distinguished themselves in terms of good academic performance, recommendation reports, research relevance on societal and economic issues, evidence of novelty, quality of the thesis, they also outperform others, demonstrating a deep passion for environmental and sustainability research. I think I say enough in terms of superlative for them. So there is only one word that I want to say. That is congratulations to all these 5 recipients, for the award. I think they will be later on going to be presented. And also on this note also, I know some of them have brought along their families, their friends. Thank you from us. Thank you for providing your children the chance to work in this area. And thank you for your support. I think you deserve applause for that. Also, thank you for the selection panel. I think they have met quite a number of times in order to come out with this recipient. With achievement, as articulated by Prof. Tan, with achievement come responsibility. That's my next part. We hope that the award winners will continue to lead the change in environmental and sustainable development, as well as preserve the precious resources of our Earth. I understand this will entail multi-scale issues that they need to tackle. It's our belief that active research into new technology, the deployment of innovative solutions to environmental issues, and sustainable use of Earth resources will help to shift the way how we consume our resources. And to all of us, this is certainly a very exciting and worthy cause to support. Once again, well done. And I certainly hope that this award is not the end, but it's just a start, a catalyst towards better things to come. And with that, we would like to really challenge you that don't just aim for the award, but aim to be somebody in this field in the years to come. Once again, we would like to thank Dr. Feng Lun and their board members for their generous support in this endeavor. And we would like to continue to work closely with them in future. Thank you very much.
Now, please join me in welcoming our honorable guest, Chairman of the World Future Foundation, Dr. Feng Lun, to give his speech. Dr. Feng, please.
尊敬的各位来宾、各位同学，大家早上好。I'm sorry.
A very good morning to you, ladies and gentlemen, distinguished guests.
世界未来基金会是迄今为止唯一的由中国公民在新加坡设立的一个公益基金。
WFF is currently the only fund that is set up by private entrepreneurs from China in Singapore.
这项基金呢，主要是用来支持可持续发展的问题的研究和一些活动。
This foundation is set up primarily to support research in environmental sustainability.
今天呢是这个奖项的第3次的颁奖，但是呢，这是一个非常重要的时刻。在这个时刻呢，不仅有过往的历次获奖的一些同学呢，也回到学校来，更重要的是，包括各位贵宾的到来，给我们以非常大的一个支持。
Now, today, this is the 3rd time we have the PhD Prize Award ceremony, and this is a very important ceremony because today we have not just the past winners with us today, but also distinguished guests with us.
特别是我要提到，就是中国驻新加坡大使魏巍先生的到来呢，对我们这个基金会和这项项目的支持是尤为重要的。
We are also very honored to have Ambassador Wei Wei with us today, which shows how much support he has for the foundation.
关于可持续发展的问题有非常之多，我们不可能穷尽所有的领域和所有的事情。我们呢，只是和新加坡国立大学还有南洋大学这2所大学呢，在一些专业的领域，包括水资源的问题，还有城市规划的问题当中展开长期的合作。 我们希望呢，这项奖项呢，不是停留在每年的这个颁奖典礼上，而是把这个奖励的过程和支持的过程把它延续。我们也在推动呢事后的，包括一些风险投资的一个工作，也就是获奖的学生，也可以如果要创业，我们后续呢提供一些风险性的投资，同时呢，我们也会做一些更多的交流，资助他们呢参加原有的研究领域的更多的国际性的活动。
Now, of course, there are many solutions that one can come up with in the field of environmentally sustainability. It's impossible to engage in research in all of these fields, so we are primarily collaborating with NUS and NTU to concentrate on certain areas, specialized areas such as water resource and city planning. Now, I hope that this award will not just stop here today. It does not just end here with the prize ceremony. I hope that the benefits brought about by this research will continue to go on infinitely. Later on, we will also be investing in some risk to help with the risk investments to help students who wish to continue to set up their own businesses, to be entrepreneurs. We hope that they will continue to do their work on this front. And later on, we will also arrange for some sessions, interactive sessions, so that students can continue to communicate and interact with the international community on this field.
我们未来呢有计划呢，使这个奖项呢变成一个长期的奖项，同时呢也要坚持把它的范围，就是我们来支持这个奖项的支持者的范围呢也要扩大。所以今天我也邀请了我们中国的企业家魏峰先生呢也参加今天的活动。我们希望能有更多的支持可持续发展的人士来参与到这样一个基金会和这个奖项当中。
We have plans. We hope that this prize ceremony will continue to go on. It's a long-term kind of investment, and we hope to have support from people from all fields, not just limited fields. That is why I'm very honored to invite a very famous Chinese entrepreneur, Wei Feng, with us today. I hope that we will get the support from people from all fields.
一个事件，它的价值除了在瞬间的闪光之外，有时候是需要时间来度量的。
I hope that this will not just be a short-term value, because it is not just a blossom, a temporary blossom. It needs time to be cultivated.
所以我们有信心使这个可持续发展的研究和这项奖项成为长期的、权威性的和有价值的一个奖项。
I'm very confident that this Environmental Research and Sustainability PhD Prize Award will continue to grow and become one that is internationally renowned.
所以我非常真诚地感谢所有到场的嘉宾，也包括同学，特别是国大、南大，还有相关的专家、老师对这项奖项倾注的心力。我也希望我们能够有更长期、更紧密的合作，使已经始于足下的所有的行动，在未来20年、50年以后回过头来看，更具有价值，更具有前瞻性，也更对整个社会有很好的一个贡献。
So this is why I wish to thank all our guests today, distinguished guests as well as students and teachers from NUS and NTU for your support. I hope to have engaged in long-term cooperation with you, and our current project will continue to go on. And in the next 20 or 50 years, we can see the benefits being reaped and bring benefits to this society, international community as well.
最后呢，也希望我自己也有进步，以后呢，我能用新的历史跟大家讲话。谢谢大家。
I too hope that I continue to improve.
Thank you, Dr. Feng. Next, let us invite the Managing Director of the World Future Foundation, Mr. Lu Bo, to speak to us.
Good morning, everyone. I'd like to take this opportunity to give you a very brief introduction on World Future Foundation and the PhD Prize. Since someone here today is new to the prize, so I'd like to give you a brief introduction. World Future Foundation is incorporated in Singapore on August 28, 2008, and later on approved by the Singapore government as a charity on February 20, 2009. And we are based in Singapore, but for the world. And we are focusing on environmental and sustainability issues. We have 3 focuses: urban development, water resources management, and energy development. About the World Future Foundation PhD Prize, it is the first of its kind worldwide because it is the first prize focusing on PhD students in the environmental and the sustainability fields. And it is the only academic award for doctoral dissertation in Singapore. And as everybody knows, it is also the largest monetary academic award in Singapore. So every winners of each year will receive $10,000 US. And we don't have any restriction on applicants' nationalities. It's open to all PhD students studying at NTU and NUS. In order to encourage the winning students to continue their research after graduation, we set up a very unique grad structure. So all the students attending, all the winning students today will receive, we split the prize amount to 2 parts. So today we'll give the first part of all the winning students on the award ceremony. And if he or she can publish a research paper in the relevant fields within 12 months from today, then he or she will receive the second part of the award amount. And according to our previous experience, in the past 2 years, all winners have finally received their second part of prize. So don't worry. Look at the trophy. We have a picture here and we have the trophy here. So the trophy was designed by a NUS student. So it means prosperity and hope. That is the 6 features of the prize. This is a milestone of the prize in the past 3 years. On April 1st, 2010, Dr. Feng came to Singapore and signed the 1-year gift agreement with NUS and NTU respectively. And then we start the first year's PhD prize, and we start an award design competition in NUS. So around 100 students majored in industrial design participate in that competition. And finally, we got this design. And in July 13th and 14th, we held the award ceremony at NUS and NTU respectively. That is for the first year. And I think some of you was winners of the first year. Yeah. Thank you. And because of the great success of the first year, WFF decides to continually support the prize for another 5 years. So our chairman, Dr. Feng, came to sign the gift agreement for another 5 years on May 18th, 2011. And also, starting from the second year, we decided to combine the 2 award ceremonies together. So in 2011, we held it at NTU, which is on July 7th. And this year, it comes to NUS. In the past 2 years, the PhD prize attract media attention, local media attention, Here you can see some news clippings from both English and Chinese media. Well, those are the former winners. This is from NUS 2010. Okay. From NTU 2010. This is from NUS 2011. NTU 2011. And of course, in a few minutes, we will know who are the winners of this year. So on behalf of World Future Foundation, I would like to congratulate the winners of this year and express my sincerely thanks to our dear colleagues from both NUS and NTU. I truly believe that with this prize and the great research you have been doing at specific areas, we have the power to make a serious impact on future generations and make this world a better place to live in. Finally, I'd like to end my speech today with a very meaningful quote from Ross Perot. The activist is not the man who says the river is dirty. The activist is the man who cleans up the river. Thank you.
Thank you, Mr. Lu, for your speech. Now is the prouder moment. Now is the prouder moment for our winners of the WFF PhD Prize. Let us invite Dr. Feng Lun and Professor Tan Tian Sun to come forward to present the prize to the winners from the National University of Singapore. They are first Dr. Chen Jie. Dr. Panu Sukitpaninit. Dr. Saravanan Kupan. Dr. Wei Yuting. Dr. Zhang Wei. Now, I would like to invite His Excellency Wei Wei, Mrs. Vanaja, Mr. Sun Zhiping, and all WFF board members to join the 5 winners from NUS to take a group photo.
Okay, thank you.
Thank you, Professor Tan. Thank you, Prof. Tan, His Excellency Wei Wei, Mrs. Vanaja, Mr. Sun, Dr. Feng, and the board members. Please return to your seats now. Next, we would like to invite Dr. Feng Lun again and Professor Lai Sun Wa to come forward to present the awards to the 5 winners from NTU. They are Dr. Ang Kong Kong Kwa, Dr. Zhang Wei, Dr. Li Aidan, Dr. Li Aidan first. Dr. 张伟。Dr. 刘杰华。Dr. Grace Wei 次印。I would like to invite His Excellency Wei Wei, Mrs. Vanaja, Mr. Sun, and the WFF board members to join the 5 winners from NTU to take a group photo.
Okay, everybody look here. Okay, 1, 2, 3. 1, 2, 3. Last one. Thank you.
Thank you, His Excellency Wei Wei, Mrs. Vanaja, Mr. Sun, Dr. Feng, Professor Lai, and the board members. Please return to your seats now. It is believed that the World Future Foundation PhD Prize will encourage and inspire the graduates to continue seeking breakthroughs in their research fields. Next, let us invite our current and past winners to share with us their research milestones. Firstly, we have 5 current winners from NUS. Dr. Chen Jie.
Good morning, distinguished guests, colleagues, friends, ladies and gentlemen. My name is Chen Jie. I'm from Department of Physics, National University of Singapore. Today, I'm very honored here to share with you my research progress. The title of my PhD thesis is Theoretical Investigation on Thermal Properties of Silicon-Based Nanostructures. Nowadays, about 90% of the world's power are generated by heat engines which operate typically at an efficiency of 30 to 40%. As a result, a large amount of heat energy is unused but dissipated to the environment. Thermoelectric material can harvest useful electrical energy from this wasted heat energy for sustainable energy supply, thus have attracted wide attention in recent years. I began this PhD project in early 2008. Right after the groundbreaking works from 2 US groups from UC Berkeley and Caltech demonstrating the feasibility in experiment to use silicon nanowires as efficient thermoelectric material. The goal of my thesis is to identify efficient strategies that can further enhance the thermoelectric performance of silicon nanowires through novel design of novel control of thermal properties. I spent the second year of my candidature learning the relevant simulation techniques involved in the project. During that time, I have also brought new development to the existing simulation techniques. Based on my developed simulation methods, I carried out the proposed research project during 2009 to 2011. In last year, I summarized all the research results and finished my PhD thesis. In terms of output, this thesis project results in a total number of 7 publications in international peer-reviewed journals, including 1 in Nanoletters and 3 oral presentations, 1 poster presentations in international conferences. Next slide, please. After the submission of thesis, there are some recent progress this year on the thermal properties of other kinds of nanowire as well, such as germanium nanowire and the zinc oxide nanowire. The ongoing works include the thermal transport in multiple layers of graphene, the thermal contact resistance across nanoscale silicon dioxide and silicon interface, and 1 invited book chapter on the molecular dynamics simulation techniques in calculating thermal conductivity of nanowires. In these works, the financial support from World Future Foundation has been acknowledged. Lastly, I want to use this opportunity to express my sincere gratitude to my supervisor, Prof. Li, at NUS for his guidance and support during my candidature. Also to Prof. Zhang from Peking University for long-time collaborations. I'm also very grateful for the financial support from President Graduate Fellowship at NUS throughout my candidature. Lastly, I want to thank World Future Foundation for today's PhD thesis prize and today's opportunity to present my research work here. With that, I will end my talk. Thank you very much for your attention.
Dr. Panosuke Panini.
Good morning, all distinguished guests, friends, colleagues, ladies and gentlemen. My name is Panuskit Paninit from NUS, Faculty of Engineering, and today I would like to share with you of my research work. Energy and environmental issues have become a major global concern. Biofuels, which can be produced from non-food biomass or microalgae, is recognized as one of the promising alternative fuel source in many countries. However, a major challenge associated with the implementation and growth of these sustainable biofuels is the lack of the efficient separation and purification technologies. Therefore, in my research, we have addressed and developed the novel membrane technologies based on the hollow fibers evaporation to pursue the more efficient and cleaner separation process for the biofuels. Next slide, please. Okay. In this study, we have established many new findings and knowledge on the PVDF hollow fibers membranes. The new mass transport mechanisms have already addressed advanced spinning technologies, and nano-composite materials concept have been used to design our membranes in order to fabricate the membranes with a good performance and meet the real application in the industry. And the right-hand side, the plot between the separation factor and flux, which is used to evaluate the membrane's performance. We compare our membrane's performance with other membranes available in the literature. It can be seen that our membranes show a better performance compared to most membranes available here. We believe that the membranes may represent a new class of industrial membranes for the biofuels recovery application. So finally, I would like to thank thank my supervisor, Professor Niu Chong, our friends in the lab, and my family to support this. I also would like to acknowledge the World Future Foundation to give me this opportunity to continue the research and also this award. Thank you very much. Thank you.
Dr. Saravanan Kupan.
Hi, good morning. I'm Saravanan from Faculty of Science. I did my PhD with Prof. J.J. Vittal and Dr. Parni. So, all these days we have enjoyed burning fossil fuel for our transportation and other energy needs. But at the same time, we have caused irreversible damage to our environment. Okay, so research on sustainable energy resources is very important these days. But all these sustainable energy resources are intermittent. It means they restricted by time and space. Therefore, energy storage is crucial to back up this clean energy. Among the various energy storage devices, lithium-ion batteries are very potential device. Currently, this power fully the consumer electronics. However, to power the electric vehicles and power grid, it needs developments. So these are the 4 important areas for the developments. Currently, the state-of-the-art lithium-ion battery uses lithium cobalt oxide and graphite as the electrode material, but that is explosive in nature. Whereas we developed the lithium manganese phosphate and iron phosphate based material which is completely safe in nature. Now also cobalt is pricey, therefore the battery is expensive. We developed the iron based battery is quite cheap. And cobalt is toxic, whereas the iron based material we developed is completely environmental friendly. And also the battery we developed have the higher energy density compared with the existing batteries. And we have published our work in energy and environmental science, and it's also featured as the cover page in the energy and environmental science. We have patented our work. Later, it was supported by NRF to mass produce our product. And we have published our phosphate-based battery work on the JMC and also featured as the cover page. And these are the other patents and publications out of my PhD. So I would like to thank my colleagues in chemistry and engineering. And also I would like to thank my supervisor. And also I would like to thank World Future Foundation for giving me this opportunity to present my work on the award. Thank you.
Dr. Wei Yuting.
I'm Wei Yuting from Civil and Environmental Engineering in the US. Today I'll be here to share my research development, which focuses on removal of anionic contaminants by environmental friendly engineered materials. First, I'd like to highlight the motivation for my PhD studies. Consumption of boron and arsenic-containing water may result some adverse effects on living species, such as if the irrigation water with excess boron, it can cause boron toxicity. For example, the yellowish spots on the leaves or in the surrounding areas, or finally to cause the plant's decay. So the table here lists the maximum concentration of boron in irrigation water for agricultural crops. For example, for the blackberry, it should be less than 0.5 ppm. Arsenic is another well-known toxic contaminant. If the drinking water contains high level of arsenic, it can cause chronic effects such as cancer or finally the acute lethality. Arsenic contamination is not only one nation problem, actually it's a worldwide issue. The WHO and the US EPA has regulated the arsenic, the maximum contaminant level in the drinking water should be less than 10 ppb, not 0.1. Okay, the next. Okay, so our aim was to seek a novel solution for this boron and arsenic challenge. As well known, Singapore has abundant resources for the seafood. Actually, after the distillation of the seafood shells, we can get the chitosan, one kind of biopolymers, which is low cost and environmental friendly materials. These chitosan flakes can be reshaped into the chitosan beads, and to do the cross-link reaction. After drying, these particles can further modified by via ATRP and further NMDG functionalization. Sorption studies is one of the important tests for our performance evaluation. As shown here, the sorption capability of the modified chitosans are several times higher than the raw ones, and also higher than the commercial resin embolite IRA. Actually, we did a wide series of sorption experiments. Due to the time limitation, we cannot release it one by one. Actually, based on our overall studies, we find our materials showed competitive advantage with most other adsorbents in the literature report. That's the end of my presentation. Finally, I'd like to thank NUS, thanks my PhD supervisor, Dr. Chen's support, and finally thanks to WFF Prize Foundation. Thank you.
Dr. Zhang Wei.
Good morning, everyone. I'm Zhang Wei from NUS Faculty of Engineering. So I'm very glad here to show some of my research progress here. So next slide. So my PhD study is focused on the low cost and high performance dye-sensitized solar cells. So solar cell is a kind of electronic devices that can convert sunlight into electricity. It's a green technology that can produce clean and renewable energy resources. So compared to the conventional silicon solar cells, my devices has several advantages as listed below. So first, I will introduce the structure of our devices. The active layer of my devices is a nanocrystalline Ki2 mixed layer, which is anchored by dye molecules, which is filled by the supposed by the whole transporter materials, and this active layer is sandwiched between conducting substrates such as FTO glass and the counter electrodes. So several device samples are shown in the right pictures. You can see that they are different colors because the dye molecules has different colors. So compared to the silicon solar cells, our devices has several features such as low cost because the materials we used and the fabrication process is very simple and cost effective. Another is the lightweight and flexible. If we fabricate devices on plastic substrates, and its transparency and colorful as shown in the right pictures. But for example, for the silicon solar cell, it's not transparent and opaque. And the most important one is the high performance. So currently, 12% record efficiency has been achieved in this field. Next slide, please. So my devices is very promising in the future. For example, they can got very wide applications, such as the flexible power supply to charge mobile phones, as the smart window materials to decorate the windows indoors, which can reduce the electricity we used for the buildings, or it can be used as the power roof for outdoor applications. Another important application is used as decoration materials, such as solar leaves. It's decoration material but can produce electricity. So very important breakthrough is made in this year, that is the efficiency of these devices has been improved as comparable to the silicon solar cells. So I believe that such kind of devices has very good, bright futures, which should shelve the marketplace for the silicon solar cells. Finally, I'd like to thank NUS to provide the scholarship. I'd like to thank my supervisor, Prof. Liu Bing, to guide my PhD study. And finally, I'd like to thank World Future Foundation to provide such valuable award for me. Thank you very much.
The following are 3 winners from NUS in 2011. Dr. Liu Hongjun.
Distinguished guests, the winners, ladies and gentlemen, it's my honor here to introduce you my recent exciting clean tech venture after I received the last year WFF Prize. I'm Liu Hongjun from the NUS Chemistry Department, Faculty of Science. Get expressed. Okay, I spent most of the time of the past year on this project called a solution process for hybridized individual materials for printing organic photovoltaics. Basically, as Dr. Zhang just introduced you, organic photovoltaics and as well as DSS, dye-synthesized solar cell are the third generation of solar cell for new energy resources. My job is to develop the new interface materials as well as the process to produce the solar panels. And fortunately, for this project, with our collaboration with a lot of group members, we have produced 2 material systems there. We got 3 publications as well as 1 patent, provisional patent. Next, please. Meanwhile, we take the concept to use the organic photovoltaics active material to do organic reactions, which means we develop the organic catalyst to capture the sunlight to produce new organic compounds for medicinal chemistry usage. These 2 projects was completed by in A-Star, Emory. Okay, actually, for a long time I have idea to get involved in the business entrepreneurship, but frankly speaking, we do not know what's the direction. Thanks for Dr. Feng's book. I learned about the corporate responsibility. Followed by that, we learned about the social entrepreneurship. Next, please. Then, in this year, in March, we formed the AG Plus, which is a tech social enterprise company. We focus on solving social problems by developing technology and products, as well as to generate profit for a sustainable development. What our current concern is on the water. Maybe you know that currently there are around 800 million people still lack of access safe drinking water. What our current job is to develop portable water purifier to provide a small product for everyone that can get safe water resources for everybody. We made great process now, and I hope I can show you the product next time. Okay, with that, I would like to thank to all my colleagues, my team, especially for WFF, for your inspiration that we pursue our enterprise work. Thank you.
Dr. Augustine Quack.
Hi, my name is Augustine. Let's see. Okay, it works. I'll make this easy to understand and quick. My research has been so far in the past year or so consists of energy, renewable energy, and one of the ways, other than solar photovoltaics, which you have seen, is to use hydrothermal treatment of existing carbonaceous waste. Okay, so what is hydrothermal treatment? I just go through quickly. So we can do this with solid waste. We can do this with hydrothermal treatment, which is to use water to degrade organic compounds. Okay, so under high temperature and high pressure, these carbonaceous compounds can become a coal-like substance. So in actual fact, we are increasing the rate of coalification to make it more into a kind of coal. So I'll show you a short presentation. When you heat up water and you have a piece of waste solid material, and you increase the temperature such that vapor starts to form, you are actually increasing the pressure inside this reactor. Okay, you do not allow any gases to escape, so you can increase the pressure. If you increase it enough, the water starts to dissolve the organic compounds, and what you get is a coal-like substance. Okay, so my research actually stopped here. Some people have actually gone further, and they have made one state of water, which is a supercritical state. That is a very high temperature and pressure, but I actually stopped there. And we have many applications, because if you can reduce any organic waste into a coal-like substance, essentially you can convert it into a fuel. This is a result. Okay, instead of showing you papers and publications, I rather show you the results. On the other side of this table is what you can see. This represents the high heating value, and lignite is a form of coal. It has a high heating value of 28.4, thereabout. This is what we have, all right? It's not necessarily 28.4, but it's close. And you can see that we can actually convert coconut fiber, eucalyptus leaves, even newspaper into a value that is very close to the heating value of coal. Okay, so this is what my research is currently focused on. We are trying to see what is the best way to convert waste materials into coal, and whether we can actually use this coal to provide energy. Okay, we have done some coal combustion. We have done some optimization studies. Okay, and the studies are still ongoing. Okay, this is my presentation today. Thank you.
Dr. Mano.
I'm Dr. Mano I was from NUS. Now I am in BCA Academy. I'm a lecturer there. I have not pursued my research work, but I can give you some insights about BCA Academy. Okay, I was last year's recipient of the WFF Prize. I'm grateful to the WFF committee and NUS lecturers for guiding me. Okay, BCA Academy is the education and research arm of the Building and Construction Authority of Singapore. We champion in the development of an excellent built environment for Singapore. Okay, we train students, professionals for the manpower needs of the built environment. Okay, for my case, I teach diploma plus university students, part-time university students. Okay, to lead by example, we retrofitted our BCA Academy itself using green technologies. So these are some of the features we have incorporated in the zero energy building. ZEB means zero energy building. So we have installed photovoltaic modules, light shafts, vertical greenery, light pipes. I would like to thank you.
Dr. Steve Cardinal from the inaugural batch in 2010.
I'm Dr. Steve from NUS. Now I'm still working as a research fellow with the Center for Sustainable Asian Cities in School of Design and Environment. I'm going to share with you these are research roadmap that I've published in landscape and urban planning. My PhD work was actually only the small part that I developed an air temperature prediction model to predict the impact of the air temperature due to the urbanization or development of an area. Now, in this, in terms of achieving a more sustainable city development, there's a long way to go where we need more comprehensive, complex system and simulation models. So currently, I'm working to develop further on the wind aspect, on the solar aspect. And then we just recently secured another grant to work with Shanghai Chiao Tung University under NRF funding to link up between the real-time urban climatic monitoring with the simulation models. In the long run, we are also now working to develop another proposal that integrate this urban simulation modeling 3D model from the designers, link up with the simulation models that later on can predict what is the urban livability index or any other indices that we can develop further. So currently I'm working for this project, Islandwide and Marina Bay Climatic Mapping, which is as a start of my result of my PhD work. And then I'm proud to inform you that yesterday we just made a presentation with the CEO of the Urban Redevelopment Authority and the CEO of Housing Development Board. And they has agreed to support us further to continue this research, which subsequently will use our island-wide climatic mapping to develop guidelines for them in implementing the development of Singapore. As you know that Singapore, it keeps building a new townships, developing Marina Bay, building a new CBD. Then they need a more integrated tools for them to guide the planners on how to develop the city more sustainably and climatic friendly cities. I'm working also for Punggol Township Climatic Mapping. I'm working with NEA on the climate change projects, which try to relate the relationship between the air temperature or changes with the energy building energy consumption. And then I'm also proud to working on this to further develop the STIF tool with JTC Corporation, in which previously supported my PhD research. And this is the one that I'm talking about with the Shanghai Chiao Tung University. Thank you very much.
Also, I would like to share with you my research progress. My name is Wang Yan. I'm from the inaugural batch 2010. When I studied my PhD, I studied in Department of Chemistry, Faculty of Science. Now I'm a research fellow in the Department of Chemical Engineering. My research work since graduation is mainly focused on the pervaporation dehydration of organic solvents via PBI-based membranes. As we are knowing, there are many important chemicals in the chemical and pharmaceutical industries, such as ethylene glycol, acetone, acetic acid, and some others. In my research work, I use the membrane-based pervaporation technology. I use this polybenzene midazoyl commercial aromatic polymers as a membrane material to carry on the separation target depending on the mixture to be separated. I have several publications since graduation. In my research work, in order to achieve a higher separation efficiency, I need to do various modifications. Those modifications can be chemical modifications such as cross-linking, grafting, sulfonation, etc. Can also be physical modification. In the physical modification, I will use various membrane morphologies. It could be fleshy membrane, hollow fiber membrane, single-layer membrane, or multi-layer composing membranes. Here is one example of the separation result in my research work. As you can see in this figure, we developed a novel sulfonated PBI membrane for the separation of acetic acid water mixture. The separation performance of this PBI membrane showed a superior performance as compared to other polymeric membranes in terms of permeation flux and separation factor. I would like to thank NUS, my supervisor, Professor Niel Chung, and WFF giving me this chance to continue my research. Thank you, all of you. Next, let us invite our peers from Nanyang Technological University to share with us their research milestones. The first winner is Dr. Ang Kong Kong Kwa.
I'm the chairman of WFF and managing director, distinguished guests, and ladies and gentlemen. Very good morning to all of you. I'm Ang Kong Kong from School of Electrical and Electronic Engineering of Nanyang Technological University. First of all, I would like to thank WFF for giving me this prestigious award. And then the topic of my PhD thesis is the design and fabrication of exotonic solar cells. So first, I would like to briefly explain on the motivation of my research. As you all know that because of the environmental issues and global energy demand, the needs of the solar cell is important. However, nowadays solar cells, the usage of the solar cell is very limited because of the high price in silicon solar cells. Basically, silicon solar cell is the price is very high. So the motivation of our research is to find a new technology to reduce the cost of the solar cells. Basically, that's why very important to have the new third generation solar cell. We call it the exotonic solar cells. This solar cell can reduce the cost tremendously because those kind of material can be produced from the solution process material at the low temperature. And then because of that process, we can use that as the road-to-road manufacturing, and that will reduce the cost tremendously. So in our research, I did in the two types. One is the organic solar cell, is shown on the right diagram. And another one is I also working on the dye-synthesized solar cells. So in organic solar cells, we have this the acceptor and donor material and mixed together to make the charge separation. Basically, the donor material is the polymer, like as shown in the diagram, and the acceptor material, we use the fullerene-based material. The charge separation happens at this interface. So the implementation of my work is basically to get the better stability of the organic solar cell by reversing the charge polarity of the electrodes. So now let's take a look at the milestone of our research. I don't present the milestone of my own research, but instead I will want to share with you the globe is the target of the whole community. Basically, this organic solar cell is starting at the 1990 at efficiency 4%, but the efficiency increased very quickly, and then nowadays we can achieve the efficiency about 10%. So our target for this research is to get the efficiency 50%. Right now, I'm working at the University of California, Santa Barbara, and with the chemists and then also the material science to achieve this target. So hopefully we can achieve the 15% efficiency in the near future, and then it can commercialize in very near future. So finally, I want to thank WFF for awarding this, it's giving me this prize. And also, I would like to thank my thesis advisor, Professor Sun Xiaowei, for financially support during my PhD. And as well as, I would like to thank A-STAR for giving me the international fellowship to continue my postdoctoral at the University of California, Santa Barbara. Thank you very much.
Dr. Li Aidan.
And I'm so happy I have a chance to stand here to present my work, and thank you World Future Foundation. Actually, here's my thesis topic. My thesis is about polymer electromembrane fuel cell. My thesis work is experimental and the theoretical study of the cathode catalyst layer. Here, I think I want to talk about the environmental issue first. I think it is well known that the climate change and the shortage of resource has attracting more and more attention recently. So from conventional energy device plant, you see a lot of emission coming out from, and this is seriously impact our current climate. So here is a fuel cell picture. You see from the solar, we have energy from the solar, and we use electrolyzer to produce hydrogen, and use this hydrogen will go to PEM fuel cell. This PEM fuel cell is one of the favorable options for future green energy. From this picture, you will know that how a fuel cell works. The hydrogen will go into the anode, and in the anode, it will decompose into the proton and the electrons. The electrons, of course, you can use as a current, and the proton will move inside, and then you will go to the cathode. In the cathode, the proton will combine with electron and air, oxygen from the air, and the water is the only byproduct. And the advantage of the PEM fuel cell is so obvious that it is low noise, no vibration, and it is a green energy source. There's no gas emission. The only byproduct is water. The efficiency is so high, it can reach 60% and 70%. And the fuel cell can be made from 1 watt to 1 megawatt. The range is very wide. Here is the product from our company. Actually, I currently work in an energy company, Horizon Energy company. This This is a UAV. It's powered by fuel cell. Actually, it's previously powered by battery, and now it's powered by fuel cell. The flight range can be doubled. And this is a mini pack. We call it mini pack. This is a device that can charge the modern electrode device. This can meet the increased demand for this modern device. And this is a fuel cell powered car. Actually, this car, there's no emission, 0 emission. This power fuel cell. And of course, from previous, we know there's advantages, but of course, there's some challenges. The most challenge for fuel cell is water management. Water actually produced in the cathode, and too much water in the cathode will block the oxygen go into the electrode, and then the performance of the fuel cell will degradation very seriously. So the water management in the cathode need to be balanced. And another important issue for us, fuel cell, is the typically available membrane, the fuel membrane, need water to facilitate the proton conductivities. That means when too much water is removed from the cathode, the membrane will become dry, and the performance also will be degraded. So the water inside the fuel cell need to be optimized, balanced. So in my work, actually, I have successfully developed an anti-flooding cathode. And this cathode actually can improve the performance in certain conditions by 3 times of the conventional one. And also, I do some systematically experiment. I remove 1 layer in the cathode, and actually the performance even better than conventional several layer electrode. This saves cost and saves the procedure. And lastly, I have fundamentally investigated the water transporter in the cathode using a model. And I applied this anti-flooding cathode into my own build fuel cell. This is cost-effective built in our lab, and the performance is very attractive. And I also would like to take this opportunity to thank my supervisor, Chan Shu Hua, for his guiding during my PhD, and also thank NTU to give me a wonderful investigation platform. Thank you.
Dr. Zhang Wei.
Good morning, everyone. I'm Zhang Wei from NTU. This is my research. It's about the water splitting using solar energy. So by splitting water into hydrogen, we can get the clean energy source. And also, if we burn energy into water, we can clean up the water. So these are two benefits we can get from this process. The major processes for the photocatalytic water splitting, including the following three steps. The first one is called photo-assisted water electrolysis. Of course, in this process, we have to apply the electricity. And the second one is the homogeneous process. It's called artificial photosynthesis, inspired by the grape plant. And the third one is a very simple one. It's heterogeneous catalyzed by semiconductor materials. In this one, we know that in the grape plant there are two different photosynthesis systems. In photosynthesis system 2, the water will be oxidized into oxygen, and in photosystem 1, part of the reaction, hydrogen will be reduced to produce hydrogen gas. These are part of my findings. The first one is the heterogeneous process. We use candium sulfide as a semiconductor material to absorb the visible light. Then we use nickel sulfide on the surface as a hydrogen production catalyst. So based on this process, we can produce hydrogen from water. This system has a very high efficiency. The quantum efficiency is 51% at 420 nanometers. The second one is a homogeneous process. It's similar with the photosynthesis system. So we have a photosynthesizer which can absorb the visible light. And this photosynthesizer will pass the energy and the electron to the catalyst. This catalyst will produce hydrogen. So this is another example for the hydrogen production. So today I want to thank my supervisor, the members in my research group, and also NTU, and also the foundation. Thank you.
Dr. Liu Jiehua.
My PhD work has selected for WFF PhD Prize in Environmental and Sustainability Research. My scope focuses on two-dimensional architecture for nanocatalyst and electrode materials. So we developed 6 kinds of nanomaterials for and apply them used for lithium-ion batteries, solar fuels, and solar cells. Part of our work has been highlighted on the nature's materials and nanoworks. For example, our work nanopearls, CDS-PT, photocatalyst nanoseeds. This catalyst can be used in our water buffet system to form a nanoreactor system. That's the system with a higher efficiency, about 50 higher efficiency than the single system. So this work was highlighted by the Nature Asia materials. We also synthesized the ultrasilicate billet, the nanoseed synchronized only 1 nanometers. The fluxless nanoseeds, here we synthesized the sandwich-like and wave-like nanoseed used for ultra-fast charging lithium batteries. So due to the unique structures with the open channels for lithium diffusing and storage, so its charging time can be shortened to 50 minutes, 55 minutes or less. This work also highlighted by nanoworks. Another example is titanium oxide nanoseeds with exposed facets 1O facet. So this kind of material can be used for solar cells. It's lighter to electricity and conversion efficiency can improve to 7%. So this is because its surface energy is very low, very stable. So this kind of material have long life. In my future career, I will continue to focus on the environmental and energy issues. I would like to thank my supervisor, Professor Liu Xiuwei, and thanks to the WFF PhD Prize, a green catalyst. Thank you.
Dr. Wei Ciying.
Hi, good afternoon, everyone. My name is Grace, and it's my pleasure today to share with you my PhD research findings, mainly focusing on the scientific study and also development of a printed supercapacitors. So I will first start with a brief introduction of supercapacitors. So here it shows the Ragan plot that illustrates the energy density and power density of various energy storage devices available in the market, such as fuel cells, batteries, and also conventional capacitors. So energy density is the indication of how much energy that could store in the energy storage device, and the power density is the indication of how fast this energy could be delivered from the energy storage device. So as could be seen from this Ragan plot, the fuel cell and batteries, they can store high amount of energy, but then they suffer from low power density, which means that they couldn't deliver the energy as fast as compared to conventional capacitors. So in comparison, conventional capacitors can only store a limited amount of energy. So supercapacitors is an unique energy storage device that it bridges the energy and power density gap between the batteries and conventional capacitors, and this makes it important for various energy storage applications. So here shows the commercial supercapacitor that's currently available in the market. So they have the energy density ranging from 1 to 10 watt-hour per kilogram, and the power density up to 10 kilowatt per kilogram. And they are mainly used in applications such as power backup for memory devices, energy storage for electric vehicles, mainly is just to supply the pulse power to start the electric vehicles, and also a storage for electricity generated from renewable sources such as solar cells. However, these commercial supercapacitors currently available in the market face certain challenges, such as they are bulky in size, and also some of the metallic components that's currently used in these commercial supercapacitors is non-printable, and therefore they are not compatible with the manufacturing process of some printed electronic devices, such as RFID tag, medical devices, flexible phone, e-paper, and wearable displays. So this has actually motivated and also inspired my research to develop a printed supercapacitors. So the purpose is to transform the bulky commercial supercapacitors into a printable device architecture, which is thinner, lighter, flexible, and more importantly, it is able to integrate it into all the printed electronic devices. So in short, actually printed power or printed energy storage is definitely needed to further develop the printed electronic field. So to achieve this purpose, or to realize these printed supercapacitors, we have taken two approaches. So first is come up with the new design of the device architecture. And for this first approach, and secondly is to actually utilization of new materials in the supercapacitors. So for the first approach, the electrodes has been, a fully printed electrodes has been developed using a carbon nanotube network. A carbon nanotube is a conducting material, so we could use it to replace the metallic current collector that is used in the commercial supercapacitors. And secondly is to implement this printable polymer electrolytes in the device to replace the liquid electrolyte that is non-printable in the commercial supercapacitors. So in combination with the fully printed electrodes and electrolytes, we have successfully come out with the all-solid-state fully printed supercapacitors. To further enhance the performance of these printed supercapacitors, I've utilized some new materials in my device, such as carbon nanotubes, silver-decorated CNT, manganese oxide CNT, and also vanadium benoxide electrospun nanofibers. And we have successfully to improve these capacitance up to 250 farad per gram in organic electrolytes. So for the milestone for this project, my research team hope to further improve the performance of these supercapacitors into the upright corner of this Regen plot, and therefore will develop a hybrid electrochemical capacitors in the future. I would like to acknowledge my supervisors, Prof. Subo and Prof. Madavi, my research team, my family who is always support me, and thank you, World Future Foundation. Thank you very much.
Next, we have two winners in 2011. Dr. Tai Ju Lee.
Good day, distinguished guests and everyone. I'm Juni, the last year award recipient. My project, my award-winning project, is on exploring the potential for carbon nanotube for sensor application, which could be used for environmental and health monitoring. So throughout my PhD program, a carbon nanotube field effect transistor, CNT-FET-based immunosensor was developed. And the device, in addition to that, so I have introduced gold nanoparticle as signal enhancer on top of this platform, and in addition, combined with the competitive assay approach to lead to the high sensitivity of this detection platform. So the proposed platform has demonstrated its sensing capability on two systems. One is the detections of 2,4-dichlorophenol C-acetic acid, environmental polluting herbicide. Another one is for drug detection for morphine metabolites. So my passion for environmental protection and sustainable development continued after graduation. As a scientist in Singapore Institute of Manufacturing Technology, I was the group representative for Sustainable Manufacturing Task Force, which helped up also in the setup of Sustainable Manufacturing Center in our institute, and that was then awarded the A-Star Borderless Award and Ministry of Trade and Industry Borderless Award. And I have also give lectures for WSQ Graduate Diploma course on alternative energy. So I hope that I will continue to work on this area and hope to influence people around me to have the awareness for environmental protection. Thank you.
Dr. Jennifer Alam.
Hi, good afternoon, everyone, and distinguished guests. I am the recipient from last year's award. Before I talk into what I am doing currently, I want to emphasize on what my award was on last year. So my project, PhD project, had two parts in it. The first one was chemical functionalization of peptides and proteins. And here, this first project, we demonstrated the development and application of carbon-carbon bond forming named reactions like Mukayama aldol and India-mediated allylation in the functionalization of biomolecules. I would like to emphasize here that usually the organic reactions that I'm talking about here are run in organic solvents and under anhydrous conditions. Here we demonstrated that these reactions could be run in aqueous media and at room temperature, and the conditions were so mild that it could be applied to biomolecules. The reactions, because of the mildness of the reactions, it was able to preserve the structure of the biomolecules and their enzymatic activity. So later on, we showed the application of these reactions in the functionalization of the biomolecules at a targeted site by putting on fluorescent tags and biotin labels. And the reactions are very fast and the efficiency is very high. That's why it has the scope for the application, future scope for the application in chemical genetic studies, where it will help us to study the biological mechanisms and the functions of different proteins, which in turn will help us in drug discovery and design and delivery of new drugs. And for the next project, the second project, we attempted the synthesis of the oxatetracyclic core of this molecule. This is the oxatetracyclic core. It is an antibacterial agent with a very low nanomolar IC50 values against gram-positive microorganisms. And since it doesn't have any mammalian cell toxicity, it is a very interesting drug target. In this synthetic scheme, we attempted the synthesis in 8 steps, and where internationally most of the people are trying to make it in 10 to 20 steps. And the highlights of this scheme is that we didn't do any protection, deprotection steps. So it emphasizes on the atom economy, and also we did in 2 steps we did 1 pot reactions for 2 steps. So the whole overall sequence for the reaction is short. And because of my passion for research and the different awards and publications that my research has received, I decided to continue my career in research track. Currently, I am with Experimental Therapeutic Center under A-STAR, where we are working on the drug discovery for cancer drug candidates. As you know that in drug discovery, there are several phases, which starts from target identification and validation, which is followed by assay developments. This then goes to hit finding, and followed by the campaigns of hit to lead and lead optimization before we come to the preclinical developmental compound. And my research currently here are on these 3 areas of the drug discovery. And because of the confidentiality of the projects that we are doing right now, it's difficult for me to elaborate further on my work here. So finally, I would like to thank my supervisors, Professor Lo Tek Peng from NTU and Dr. Thomas Keller from Novartis during my PhD candidature, and my group members from the Law group and my Novartis colleagues. For funding, I would like to thank Novartis for offering me the PhD scholarship and NTU, and special thanks to World Future Foundation for recognizing my research work and giving me this award. Thanks.
Before we invite Professor Tan Tien Sun to close this event, let's invite Mrs. Vanaja, Mr. Sun Zhiping, Dr. Feng Lun, and WFF board members, Professor Tan Tien Sun, Professor Lai Sun Wo, to take a group photo with all our winners. Thank you, and please return to your seats first. Now let us invite Professor Tan Tien Sun to deliver the closing address.
First, not to worry, there will be no address. I just want to take the opportunity to thank a few people. First and foremost, I would like to thank a few invisible people, but who really the one who put the whole ceremony together. The officers from my office, led by Susanna, Tripping, and Michelle. They have worked very hard to put the whole thing together. I especially like to thank Mrs. Vanna and also Third Secretary Sun Zhiping for taking time off from their very busy schedule to come and share this very happy occasion with students from their respective country. And of course, I'd like to thank Dr. Feng Lun and Lu Po and members of the board of WFF, both for attending the ceremony to show their support, and more importantly, to show their support with the money and keep that flowing. And I also like to thank my good friend and colleague from NTU, Prof. Lai. And finally, just a small note, we're going to be a bit special. We're going to invite you to have lunch at our student dining hall for the Cinnamon College. As many of you know, Cinnamon College is one of our residential colleges, and this is where the students will gather every night for their dinner. It's a new idea we are promoting in NUS, the whole concept of residential colleges. The cook is the same. I think the dishes are the same, but we remind them because we have important guests, and we select some of the best dishes. I'm sure you will enjoy it. I've hosted a number of events there, and every time people ask, how come NUS students are eating so well? So that's our secret. Thank you very much for coming today. Thank you.
Thank you, Prof. Tan. Professor Tan has a small token for Dr. Feng as an appreciation. The award ceremony has come to an end. Thank you for joining us today. Lunch will be served in the Cinema College Dining Hall. Please enjoy there. Here is a reminder to all winners. please proceed to the seminar room 2 on this level for a meeting with WFF board members at 2 p.m. after the lunch. Thank you all of you for attending.